Hello, everybody. Welcome back. Welcome back. We are still on semester one, but on the cusp of breaking into semester two. And half of you will be returning to school in the hybrid model, so I can't wait for that. That's going to be great. But we got 2 weeks left of semester one. We've got a test to have, a very small test on sequences and series, and also any reassessments from previous stuff. So winter break is behind us. I've got 3 quick examples for you. Try to make this as short as possible. This is stuff that at some point in December 2020, we should have been pretty good at. And if you do have homework from my math lab, please find some time to finish that. So, what is the 5th term of the expansion of this? So, this is a binomial raised to the 9th power. It would be a huge, huge polynomial with 10 terms. But what's the 5th term? So the process is this. We need Pascal's triangle. There it is. So then raising a binomial to the 9th term, to the power of 9, we're looking at this row, the row that has 9 in the second number. And notice if you count these numbers, there are 10 of them. And this would be the 1st term. This would correspond to the 2nd term, 3rd, 4th. We want the 5th term. So 126 is what mathematically is called the binomial coefficient, but I'm just going to call it the Pascal number because we get it from the Pascal's triangle. So 1, 2, 3, 4, 5. The 5th term is going to begin with 126. Now, it's asking for the term singular. So you're going to have one thing here. You're not going to have any pluses or minuses. And I should say it now that please pause the video and can see if you can figure out the rest on your own, the simplified version. So the process was you took the A term, which is, whoops, I don't know, just 2x to the 3rd, and you raise that to a certain power. And you take the B term and you raise that to a certain power. But these 2 powers that I'm going to put up here and here, they will always add up to 9. But what powers do you put up there? Well, you can kind of think about it in your head, but the Pascal's triangle will help us. This is the 1st term. So at this point, the A term is going to be raised to the 9th. And it's going to go down 1 power as you move along. So this would be A to the 9th, A to the 8th, A to the 7th, A to the 6th, A to the 5th. And that's all I need. This A term right here is going to be raised to the 5th power, which means by default, this must be raised to the 4th power because these 2 exponents had to add up to this 9. Now the rest is just simplifying. So order of operations is always our master. I do not multiply 126 times 2. You're going to be very, very frustrated with your scores because that's multiplication, but exponents comes first. This 2 must be raised to the 5th power first, which is 32. And then x to the 3rd has to be raised to the 5th, which gives you x to the 15th. And then 7 has to be raised to the 4th power. What in the world is that? I have no idea. Let's see. 7 to the 4th is 2,401. So 2,401 times y to the 4th. And then now we have all multiplication. I know there's an exponent here, but that exponent is only on the x. And I don't know what x is, so that's going to stay there. But this is all multiplication. And multiplication is commutative. So what I can do, I'm not going to do it, but what's really going on here is that you can switch these 2 numbers, x to the 15th and 2,401. You can switch those because multiplication is commutative. And what you would end up having is 126 times 32 times 401. And we go to our calculator, 126 times 32 times 2,401. Don't you dare distribute because distribution is multiplication over addition, and we don't have any addition here. It's, what is that number? 9,680,832. All right. Times x to the 15th times y to the 4th, and put your pencil down and walk away. That is the correct answer. This is the fifth term in this if this binomial were expanded, if I were to torture an Algebra 1 student and tell them to expand this to take 2x to the third plus 7y, multiply by itself 9 times, and have them multiply all that stuff out, the fifth term would be this one. Okay, 2 more to go. Find the explicit and the recursive forms of this sequence. So a sequence, remember, is just a list of numbers where the domain is positive integers. So here, this is 1, 2, 3, 4, 5. I'm telling you domain values. The numbers that you see here are the range values, 3, 14, 25, etc. Now, can you see the pattern? I hope you can see that to get from one term to the next, you are adding 11. And if you can figure out the next term by just adding 11 to the previous term, you are thinking recursively, which is just dandy. You need to know how to do it recursively and explicitly. So recursively, remember RE, it relies on the previous term. So the nth term is the previous term, n minus 1, plus 11. And that's true for all n values greater than or equal to 2. What about for n equals 1? Well, you have to state that. You have to state the starting point. The first term is 3. And then you can get the second term by taking the first term plus 11. Then you can get the third term by taking the second term plus 11, and so on and so on. That's recursive. Explicitly is this, the first term plus the common difference times n minus 1. Well, the first term is 3, the common difference is 11, and n is just what term are you on? If n is 5, then you're on the fifth term, etc. And this is technically correct, but we always like to simplify. So you should really distribute that 11, combine like terms, and get this. And you see how this is like a line in slope-intercept form, where the slope is 11? That's a constant change of 11. That's why we give it a special name, slope. Last example. Same problem. Find the explicit and the recursive forms of this sequence. Now, this is not arithmetic. That's what this is. If you keep on adding or subtracting the same number, it's arithmetic. But here, to get from 125 to negative 100, I would have to subtract 225. Well, do I subtract 225 again to get to 80? No. This is not arithmetic. It is geometric. You are multiplying the same number to get from one to the next, to the next, to the next. But what number are you multiplying? If you can't see it, then let algebra serve you. 125 times something, r, which is the common ratio, equals negative 100. How would you solve for r? You would divide by 125, wouldn't you? To solve for r, that's letting algebra serve you. What number do you multiply to get from this to this? Well, this is really what you're saying mathematically. Now solve for r, divide by 125. And I go to my trusty calculator, negative 100 divided by 125 is negative 0.8. Could that be? Is it negative 0.8? And it is. You can take 125, multiply by negative negative 0.8, you get negative 100. You multiply that by, again, negative 0.8, you get 80. You multiply that by negative 0.8, you get negative 64, etc. So you get this sequence. Now, recursively is usually, I think, the easier one, but unfortunately, it's the less popular one. So let's just get recursive out of the way. Recursive relies on the previous one. So we got negative 64 because we took 80 and multiplied it by negative 0.8. Well, how do I get the fifth term? just take the previous one and multiply by negative 0.8. So in other words, this. How do I get the nth term? Take the previous one multiplied by negative 0.8. And you always have to, don't forget to identify what the first value is. The first value is 125. And then once you have the first one, you can find the second one. And when you have the second one, you can find the third one, and so on and so on. Explicitly, this is something you're going to commit to memory. This is like the exponential part of the sequences. This is the linear part up here. This would be the exponential. You have a stretch. So the first term, a1, times the base raised to the n minus 1. So for here, the first term is, of course, 125. The common ratio is negative 0.8. You raise that to n minus 1, and you're done. This is totally simplified. May God have mercy on your soul. If you try to multiply these two, you are breaking the order of operations, and it will punish you. We must do exponents first. So we're stuck here. This is totally simplified.